Hello everyone. Today we're going to figure out how do we multiply and divide rational expressions. So our objectives are going to be how to multiply and simplify a rational expression, and then also how do we divide and simplify a rational expression. So our strategy is fairly straightforward. To multiply and then simplify a rational expression, we first multiply them as fractions, then cancel any common factors. So, for example, if we want to multiply and simplify 15x squared over 4y times 8y over 9x, we will just employ the strategy that we first multiply the two fractions together. Now, I'm not going to multiply the 15 and the 8 because in the end, I'm going to have to factor them anyways to cancel out any common factors. So, I'll just merely write it as 15x squared times 8y, and all of that is over 4y times 9x. Then I will take each of these and try and factor them so I could see if I could cancel any common factors. So 15 I can write as 5 times 3, and then the x squared is x times x, and the 8y I could write as 4 times 2 times y, and then all of that is all over 4y times, now I want to think about the 9x. Notice there's a 3x up here. So it's probably convenient to write the 9x as 3 times 3x, so that this 3x here could also cancel with that 3x there. And we look to see, is there any other places where we can reduce? Yes, the numerator and the denominator share that common factor of 4, so those can cancel. And then I'll look what I have left over. And what I have left over is the expression 5 times 2, so 10xy all over y times 3, which we traditionally write as 3y. So now when I look, I see, do the 10 and the 3 share any additional factors? No, they do not. Do the x, y, and the y share any factors? Why, yes, they do. They share y. And so I will cancel those out, and I will write this now as 10x over 3, which I could see now share no common factors at all. Remember, a lot of times there's pressure to cancel out all the common factors in the first step, but as long as you're willing to, at every stage, ask yourself, did I cancel out all the common factors and cancel out any additional ones, you're going to be okay. Okay, let's look at something that's a little more complicated on how to multiply and simplify. So you could see here that in the numerator of the first fraction we have t squared minus 1, and that's over 3t squared plus 12t plus 12. And the second fraction is t plus 2 over 2t squared plus 3t plus 1. Helpful things to recognize are that number one, this numerator is a difference of squares, and that this trinomial down here has a GCF of 3. So that when it's time to factor, see that the t squared minus 1 will factor into t minus 1 times t plus 1 all over, and then I'll factor out the 3, so that becomes t squared plus 4t plus 4. And then in the second fraction, the t plus 2 is a linear factor, so those never factor additionally, at least not non-trivially. And then the t squared plus 3t plus 1 is a trinomial. And so let's see, it ends up factoring into 2t plus 1 times t plus 1. We can already see that a t plus 1 factor from the denominator of the second fraction is going to cancel with the t plus 1 from the numerator of the first fraction. But in addition to that, the numerator of the first fraction is a perfect square trinomial and therefore can factor into t plus 2 quantity squared. And thus, one of those t plus 2's can cancel with the t plus 2 in the numerator of the second fraction. So the t plus 2 here can cancel with one of them there. Just cancel out the 2 because it'll be left to the first. And we are finally left with the expression t minus 1 all over 3 times t plus 2 times 2t plus 1. In general, we do not multiply out the denominator because when we look now in factored form, it's easy to see what are the domain restrictions. We can see just by looking at them that t cannot equal -2, and similarly t cannot equal -1/2. So in order to divide and simplify a rational expression, our strategy will be pretty simple. We will first change the division to multiplication by the reciprocal, and then we just multiply and simplify. X squared minus x all over 2x plus 1 times the reciprocal, which is x minus 2 over 3x minus 3. Now we just do what we did in the previous example, which is factor each numerator and denominator and cancel out any common factors. So if I just quickly factor the first fraction, there's only a GCF of x in the top, and this is a linear factor. And down below, you should notice, that there is a GCF of 3 in that second denominator, giving us that those x minus 1's cancel, and nothing else is going to cancel. Everything is a linear factor with variables. Producing for us the simplified version of x times x minus 2 over 2x plus 1. So that ends how we multiply and divide rational expressions, and thank you very much.